Hello, and welcome to the webinar on why building your apps on Azure is better. Whether you are modernizing an existing application or building a new application from scratch, we'll discuss the what and why of building apps using Azure's Platform as a Service offerings. From there, we'll quickly discuss one of the hottest topics in the industry, DevOps, and how your organization can benefit from an automated software development system like Azure DevOps. My name is Brian Nielsen, and I will be your instructor for this webinar. I am a senior cloud training architect with Opsgility. I've been working with Microsoft Azure since its early days as both an IT pro and a developer. I've worked in the IT field for almost 25 years, and over my career, I've worked with organizations of all sizes, from small shops to Fortune 1000 companies. I helped write a book on private clouds for Microsoft Press a few years ago, and look forward to covering this topic with you. You can contact me via LinkedIn or email, and these are on the screen. Here's the agenda for the webinar. If you feel the need to ask any questions, please put it in the chat window and I will review them at the end of the webinar. In this webinar, I will help you understand what differentiates Platform as a Service from other cloud services. Additionally, I will go over some of the offerings available from Azure, talk about their versatility, and how they offer the ability to scale. Additionally, I will cover this integration available with these Paas offerings. Finally, we are going to explore the software as a service offering of Azure DevOps and the suite of products inside of it. Let's explain what Platform as a Service is and see what it provides you to other offerings in the cloud. Paas allows you to avoid the expense and complexity of buying and managing software licenses. It also provides the underlying application infrastructure and middleware. This includes container orchestrators such as Kubernetes, or the development tools and other resources. You manage the applications and services you develop, and Azure typically manages everything else. Paas offerings are ideal for teams that want to significantly reduce their time to market. They're also ideal for organizations looking to reduce operational and administrative costs. With Azure, Paas organizations are able to easily implement a chargeback model by tracking usage and support metrics. Paas applications allow for extreme cost savings on a typical budget because of the reduction in database and operating system costs, all while increasing stability. When I was first introduced to Paas offerings, it really didn't click what they were trying to accomplish. I considered myself a well-rounded architect and wasn't hindered at a notion that I needed to install and set up hardware and software. But when I did some research, let's take a look at a Paas offering called Service Bus. It is a messaging tool, so you can send and receive XML, EDI, and other message types. But what would this normally take? Normally, this would be a huge training investment in BizTalk, massive SQL servers with SD drives for caching, massive licenses for BizTalk, months of setup of connections and mapping. And now, this is just a service that is available. The decrease in operational overhead to accomplish complex tasks has dropped tremendously. Other services, like serverless applications, are a brand new concept, but they allow you to create loosely coupled code without the headache of setting up and securing web servers. When looking at Platform as a Service, let's look at how cloud offerings are normally broken up. If we start on the left under Infrastructure as a Service, or IaaS, this is where most organizations attempt to go because they can migrate existing VMs to the cloud and reduce CapEx in a data center while switching those costs to OpEx. The real value is when you look at the middle category, Platform as a Service, or Paas. If this concept is new to you, look at the difference between IaaS and Paas. You can see there's more blue pieces because those are going to be vendor managed versus the small piece where you're actually going to start providing value and starting to move things quickly through your organization and deploy things quicker and more stable and more scalable. As an organization, you're responsible for all the applications in the data. All the other services are handled by Azure. This is where you have the opportunity to rethink how applications are built, focusing on loosely coupled infrastructure where you can connect microservices together. You can scale without focusing on the underlying hardware. Loosely coupling can greatly improve application stability, resilience, maintainability, and extensibility. With a loosely coupled architecture, it becomes event-driven, and the individual components can communicate asynchronously in a much more resilient manner than monolithic applications with synchronous communications. Like IaaS, PaaS includes infrastructure, servers, storage, networking, but also middleware, development tools, business intelligence services, database management systems, and more. PaaS is designed to support the web application lifecycle, building, testing, deploying, managing, and updating. One of the fundamental goals of PaaS services is providing elasticity and scale. Developers can focus on efficient, cost-effective, and repeatable processes for the creation of high-quality applications. These applications can also be scripted out so they're reproducible in multiple environments. By building on infrastructure as a service, PaaS offers the same advantages as IaaS, but its additional features, middleware, development tools, and other business tools give you more advantages. This includes cutting coding time. PaaS development tools can cut the time it takes to code new apps with pre-coded applications components built into the platform, such as workflow, directory services, security features, search, and so on. These development tools prevent something called yak shaving. It's a term coined in the 90s at MIT to explain where a simple process is needlessly complicated by having to do a lot of other tasks to reach your goal. Spending all day long setting up a Tomcat server would be considered yak shaving versus utilizing a container that was already pre-built and ready to go to add to your environment in just minutes. Another advantage is adding development capabilities without adding staff. Platform as a service components can give your development team new capabilities without needing to add more staff with the required skills. And with Azure adding more and more programming languages, you are not restricted with a single language or operating system. Additionally, you can develop in multiple platforms, including mobile, much more easily. Some service providers give you development options for multiple platforms, such as computers, mobile devices, and browsers, making cross-platform apps quicker and easier to develop. This includes features like notifications, geolocation, and map services. You can also use sophisticated tools affordably. A pay-as-you-go model makes it possible for individuals or organizations to use sophisticated development software, business intelligence, and analytics tools so that they could not afford to purchase outright. This is very visible when you utilize artificial intelligence and machine learning. Setting up hardware and software is beyond most organizations' capability. Now it's possible to easily add image recognition or voice recognition with a simple service call without having to write complex code. You can also support geographically distributed development teams. Because the development environment is accessed over the internet, development teams can work together on projects even with team members that are in remote locations. You can also efficiently manage the application lifecycle. PaaS provides the capabilities that you need to support the web application lifecycle, building, testing, deploying, managing, and updating the same integrated environment. Let's additionally take a deeper dive into cost, scale, efficiency, platform support, application lifecycle management, and integration. When looking at the cost, consider Azure Functions as an example. Azure Functions hosts small applications like background jobs or microservices that can run in a short period of time. Azure Functions are completely serverless, and you are only charged for when they run. Here is an example of cost, and this is directly from Microsoft's site. Azure Functions consumption plan is built on a per second resource consumption and executions. Consumption plan pricing includes a monthly free grant of 1 million requests and 400,000 gigabytes of resource consumption per month per subscription. So as you can see, organizations will not only save operations costs, but in the reduction of support of administrating the underlying infrastructure. PaaS also benefits from being able to deploy Azure Resource Manager templates or ARM templates. These allow the ability to quickly and accurately reproduce environments. So when building them out, organizations no longer see snowflake servers where it does not match other environments. This is a true cost savings to eliminate potential variances across environments typically seen in on-premises environments. One of the biggest benefits from moving from IaaS to PaaS applications. The ability for Azure offerings to offer scale is one of the cloud's biggest advantages. Cloud Paas offerings also offer the ability to scale out horizontally as well as the ability to scale in. The ability to gracefully handle instances being removed. Another consideration when looking at scale is how applications are built. If you look at this picture, this is an on and off workload scenario. What happens here is that you can take advantage of this kind of scenario with Paas offerings. So if you think a large organization that works on consumer taxes, a normal data center would have underutilized hardware the majority of the year, only to have to be able to support a large user base during tax season. With Paas, you can decide the size and scale or shut down instances entirely till they are needed again. Another scenario that is difficult in a data center is when an organization is growing fast to the point where they cannot provision hardware fast enough to keep the application online. But by building applications with Paas, it has the capacity to handle high growth rates. Another advantage might be a feature you normally didn't think was going to require heavy use. Normal infrastructure planning might underestimate a particular feature scales requirements. By building that feature utilizing Paas, you can eliminate that concern. Serverless architectures allow auto-scaling and only charge when they are in use. So if you consider a public website that has a registration section, but the vast majority of your users are already registered and just logging in, those pieces of code are not wasting compute time in a typical web server. They will be completely idle, and if the organization start the campaign to register new users, the scale, capacity planning, and cost management are automatically scaled. The result is software that is easier to build, maintain, and often 99% cheaper. Another scenario for Paas offerings is unpredictable demand. If the application is a large monolithic application, there's a potential for performance degradation when high use occurs. The advantage of a Paas application is the ability to truly implement separation of function. This will inherently be able to handle unplanned spikes. Let's take a popular website and decide that if the administration site and the public site are hosted separately to the public site, it can be built to handle sudden surges in load. While the administration site can be built for a more predictable load, if the administration and the public site were hosted on the same web server, it would not only affect end users, but also the administrative portion of the site, preventing updates and/or changes. Another unique scenario is seasonal requirements and predictable demand. So you can schedule web jobs or allow DevOps to provision your environment to scale based on the needed demand. Consider a fantasy football application. The number of people utilizing the application on a Tuesday afternoon compared to a Sunday afternoon. Obviously, there's going to be a planned spike in users so the organization can plan for it. If we look at efficiency, the benefits utilizing existing Paas services to increase the efficiency of your entire development team and the efficiency of your application lifecycle management is increased because your developers can focus on bringing value and not building and supporting the underlying infrastructure. Efficiency in development is only one major feature of Paas systems because Azure not only focuses on building great services, but they also focus on building efficient data centers. This is from an article in 2018. Microsoft Cloud is between 79 to 93% more energy efficient than a traditional on-premise data center. I provided a link at the bottom of the slide to the study. And when renewable energy is taken into account, carbon emissions from the Azure compute are 92 to 98% lower than traditional on-premise data centers. Microsoft also offers a sustainability calculator to provide new insight into carbon emissions data associated with Azure services. Those responsible for reporting on and driving sustainability within their organization now have the ability to quantify the carbon impact of each Azure subscription, as well as see the estimated carbon savings from running those workloads in Azure versus on-premise data centers. The calculator gives a granular way of estimated emission savings from running workloads on Azure by accounting for Microsoft's IT operational efficiency, IT equipment efficiency, and data center infrastructure efficiency compared to that of a typical on-premise deployment. It also estimates the emission savings attributable to a customer from Microsoft's purchase of renewable energy. When considering how application lifecycle management is handled in your organization, there's an opportunity to not only deploy code as part of a continuous integration, continuous development pipeline, but also deploy the infrastructure as code. Utilizing DevOps, this allows a CI/CD pipeline to automate the creation of Azure resources that can be used for development, testing, or any environment. Azure repos can store the ARM templates and retain their respective version history. This ensures that not only does every responsible party have the latest code, they also have the latest environment. So you can be sure that everybody is on the same page. There might be a perception that by utilizing Azure, you might be stuck using .NET code, Windows servers, IIS, and similar Windows stack components. But Microsoft has been developing web apps, mobile applications, and providing customer services. Here is an example of some of the languages supported in the app service. Applications can be built to run and scale based on both Windows and Linux environments. One of the things you can do is go directly to the Azure Marketplace and install WordPress. So you can have MySQL, WordPress completely working in Azure as seamless as running a .NET application or any what normally would be a native Windows application. You can also host a simple, inexpensive website using Azure Blob Storage, where you just host static HTML pages for an extremely cheap price. This is a small list. I wanted to highlight some of the popular Paas services. This includes web apps to jumpstart your web application development. If you think of what a normal web app would be for a Windows side, where they're setting up .NET 3.5, .NET Core, setting up the actual web server, installing certificates, all these things are taken into account and automatically locked down. So you're actually ramping up and creating a fully functional website just with a few clicks. There's no administration side that's required. Next is going to be logic apps. They're great for workflow and secure integration to not only on-premises data, but many third-party services and customer services. Azure functions are small functions that can be your introduction into microservices. Azure Web Jobs are similar to Azure Functions, but are designed for running jobs, so scripting languages, including Bash, are actually allowed. Azure Event Grid acts as a glue between services. So if you want to have an event that is published and you want to notify multiple subscribers, this is the best option. Azure Service Bus is used for sending messages and events. Azure Storage is a large subset of products that includes blob storage, table storage, queue, file share, and disk options. Azure CDN provides end users with high availability and high performance of defined CSS, images, and/or scripts. Azure Redis Cache is an in-memory, high-performance database that allows for highly scalable caching mechanisms. So if you want to have a landing page or a shopping cart that is cached so you're not having to do a database call, this is something that is native directly available for you right as soon as you log in. Azure API Management allows development engagement, analytics, policy enforcement, authentication, and authorization. The Azure Service Fabric is a reliable, hyperscale microservice platform. Azure Kubernetes Service is an open source tool for container orchestration. Azure Cognitive Services is a suite of services that includes bot, machine learning, computer vision, language understanding, and form recognition. To see the comprehensive list, please visit the link at the bottom, or you can search for Azure products to see the latest available from Azure. Azure DevOps is a suite of products to provide a one-stop shop that helps every developer and organization plan projects using widely accepted Agile tools, manage code using Git, test the application, and deploy the code using continuous integration and continuous deployment. If you have been using Microsoft source controls in the past, like Visual SourceSafe or TFS, this is truly a next-generation tool. Let's start with a basic understanding of what DevOps is. It is the union of people, process, and products to enable continuous delivery of value to your end users. If that doesn't make a whole lot of sense, let me tell you a little more relatable story. There's an interesting case study from an extremely large company that they found they had a problem with existing code deployment methodologies and also with existing code bases. They found that their change sets were so large that the impact of the change was causing outages, so they decided to deploy and test smaller changes. This caused a lot of advantages. By breaking up the code so developers were no longer working on millions of lines of code, they changed their operations so they could ramp up their junior developers faster. They constantly monitored the developers' throughput and noticed that the existing IDEs took a long time to load code and even longer to build. They decided to actually write the Atom client to make development environment as light as possible. They then pushed all the build and testing to an entirely separate environment that could scale to meet the needs of thousands of developers and multiple languages. This model allowed them to continuously deploy smaller, tested code, making the organization able to rapidly meet user needs and the business requirements in an increasingly competitive market. Azure DevOps allows you to deliver software and infrastructure faster and more reliably. Azure DevOps allows continuous integration to improve software quality and speed. Azure pipelines allow for easier deployment and testing of apps in the cloud, making the ability to find bugs faster. Continuous deployment combined with infrastructure as code allows teams to achieve identical deployments with confidence. Azure boards offer proven agile tools, including Kanban boards, interactive backlogs, and planning tools. Azure pipelines allow organizations to build, test, and deploy any language to the cloud or on premises. These can run in parallel on Linux, Mac OS, and Windows, and deploy containers to individual hosts or Kubernetes. Azure repos offer unlimited free private repos with powerful Git hosting for effective code reviews and versioning. Azure test plans allow you to include tests as part of your code or have additional manual and exploratory testing. Azure Artifacts provides a universal package management library for Maven, NuGet, NPM, and Python libraries. Here's what a Kanban board looks like in the Azure boards. It includes backlogs, team dashboards, and custom reporting. It has the ability to track ideas from every development stage and link all the code changes directly to work items. Azure boards have built-in Scrum boards and planning tools to help the teams run sprints, stand-ups, and plan meetings. You can also check the health and the status of the project with powerful dashboards and analytics tools directly in the client. Azure pipelines, they actually allow the creation of multiple steps to compile, test, or even deploy code. It is extensible to any language, any platform, or any cloud, even on-premise. Best in class for open source product and ensures fast and continuous integration, continuous delivery pipelines. Azure repos offer support for any Git client and has the ability to add validations and extensions from the marketplace or build your own. Built-in semantic search that is code aware to understand the difference between classes and variables. Azure test plans, they actually offer the ability to improve code quality by using planned and exploratory testing services. Testing can include unit tests, integration tests, UI tests. These include manual and automated, manual QA testing, smoke tests, performance tests, and load tests. Azure Artifacts creates and shares Maven, NPM, and NuGet package feeds directly from public and private resources. These are fully integrated into the CI/CD pipelines and allow efficient code sharing across both teams large and small. Azure Dev Test Labs allow self-service creation of environments with control and auditing. The script can be stored in an Azure repo and deployed as part of the Azure pipeline. The organization has control of the base templates and artifacts. Multiple environments can be deployed at one time with ARM templates. The template can also include Paas resources. So coming to the conclusion of this, so I've actually gone over what Platform as a Service is and how it's available in the cloud services. Also covered the benefits of choosing Paas offerings to improve your organization's ability to create, deploy, and scale faster modern applications. After this webinar, it'll be archived on the Opsgility YouTube site. There are also previous webinars archived there. Comments will be open, so if you have any questions after the webinar, you can share them here. If you have any questions, you can actually open them in the chat right now, and I will start answering. Currently, we do not have any chat, but otherwise, I am complete. Anyone have any other questions or concerns or any ideas that they were bouncing around or had any concept that they wanted to discuss? Well, if there are no questions, I will go ahead and end this webinar. I thank everybody's time for attending. Thank you so much.